Hello everyone, this is Gayatri, Assistant Professor in the Department of ECF R&D Engineering College. In today's sessions of analog electronics, we are just going to discuss about the frequency response of amplifiers. Right? So before getting into this, let us see. In a linear amplifier analysis, always we used to assume the coupling capacitor and the bypass capacitor as a short circuit one. And in case of the AC signal, and it is going to be open circuit for the DC voltages and all. Here we will be having the intervention because of internal capacitance or interelectrode capacitance. We will be mentioning like that. Coming to the frequency response of amplifiers, okay, here we are having various factors that could vary, which are going to be the function of signal frequency. Those are voltage, current, transconductance, and transresistance. Okay. So, in case of the low frequency analysis of BJT or JFET amplifier, the coupling and the bypass capacitor are being open circuited. But still, the effect of those capacitive elements is could not be neglected. Okay, here it varies the frequency. Why? Because in the sense X is equal to 1 by 2 pi Fc. That is, at lower frequencies, Xc is going to be high, and therefore the capacitor cannot be short circuited. Whereas at a higher frequency, the capacitive reactance is going to be very low. At the same time, the capacitance cannot be open circuited. So let us see to that general concept of frequency response. So this is a RC coupled BJT amplifier operating in common emitter configuration, and the right hand side depicts the RC coupled JFET amplifier in common source configuration. In both the thing, the C1 and C2 are called the coupling capacitors, whereas here in the left hand side diagram C is the bypass capacitor, whereas in the FET amplifier CS is the bypass capacitor. So this is the amplifier gain versus frequency. That is, in the x-axis we have taken the frequency, and in the y-axis we have taken the gain in decibel. Okay. Here we are getting a graph like this. Okay. So what happens here in the sense at the ideal frequency, the frequency response remains almost flat, whereas beyond this frequency it is being lowering down. Right. Here there are three frequency ranges: low frequency range, that is this region, and mid frequency region, high frequency region, right? So those are depicted here. So the low frequency in the sense, due to the presence of coupling and the bypass capacitor, the gain is lesser. That is, at F is less than FL, the gain will be decreasing as the frequency decreases. Similarly, at the high frequency resistance, okay, high frequency region, we will be having the impact because of the stray capacitance or the interelectrode capacitance, and that's why the gain will be decreases as the frequency increases. In between this region alone is called mid-frequency region, where the gain is almost constant. Right? Here I have mentioned the audio frequency range. Okay, we know that the audio frequency range is 20 Hz to 20 kHz. Therefore, always FL should be less than 20 and FL should be always greater than 20 kHz. And that's why the bandwidth would be equal to difference of upper cutoff and lower cutoff frequency. Hope you understand this session. Thank you.